Hi everyone, welcome back. Miss Lorette here. I'm going to be walking you guys through 2.9 lesson 1. In this particular lesson, we're going to be solving questions involving percents. So you'll want a notebook, something to write with, and a calculator. If you don't have a scientific calculator, that's fine. Any basic 10-digit will work okay here. So when we're talking about percents, it's important to understand what that word means. A percent actually means a number out of 100. So it's actually a ratio. We learned in a previous lesson that a ratio is a comparison of two numbers. We can represent ratios as fractions. So if we were to represent a percent as a fraction, the denominator would be 100. So if we're looking at 24%, and hopefully everyone knows that the percent symbol looks like this actually means 24 out of 100. So when we're doing calculations involving percents, it's easiest to work with decimals. So to find the decimal version of a percent, there's a couple different ways we can do it. One way is we can divide that percent by 100, and our calculator will tell us what decimal that's equal to. So if I take 24 in my calculator and I divide it by 100, it should tell me that that equals 0.24. A shortcut is to take this percent here and take the decimal in this value as an integer and move it 2 places to the left. Okay, so if I look at 24%, there's really an invisible decimal because it's an integer. If we're looking at the percent value, we're viewing this as an integer, and we should know that in every integer, there's really an understood decimal at the very end. So I would have to add that decimal if I don't already see the decimal in the percent and move it 2 places to the left. And in doing so, this would tell me that 24% is 0.24. So when I do my problems today, I'll probably use the shortcut method, but understand that what we're really doing here is we're actually just dividing that number by 100. That's what this shortcut actually does for us. Now, there's a couple different ways to solve percent problems. There's a proportion method and there's an equation method. In this particular lesson, I'm just going to go through and use the equation method. I want my pencil. Here we go. So different textbooks will use different variables when they're showing you the different formulas, whether it's a proportion or an equation. For our particular lesson, we're just going to be using the variables P, B, and A. It doesn't really matter what variables you use. Variables are arbitrary, so long as we know what they represent. So if we're using P, we're going to say that that represents the percent. And remember that a percent is a ratio out of 100. Oftentimes, we'll refer to a part of our percent question as the base. Another way to think about this is the base is like your total. Or in other words, it's the whole. Okay, so if you think about when you take a quiz, if that quiz was worth 50 points and you earned 40 points, the base, the whole, the total, would be the 50 points that you could have earned, and your part, which we're going to say is A, would be what you earned. Okay, it's the part of the base. This is the answer that you get when you take the percent of the base. And when we're doing calculations, the base is going to be the number we're taking the percent of. And then this is the formula that we're going to be following for today's lesson. And again, this is really following the equation method of solving percent problems. There is a proportion method that I'm not going to talk about in this particular lesson. So let's actually do some examples. But before we do that, we need to kind of know when we're looking for each of those pieces, because when we're substituting things into that formula, 2 of those things will be numbers and the other one will be a variable that we're solving for. So we need to know what value goes where. So there's a few things that you can use to help you with that. Some key words that will actually help you determine which piece you have. If you see a question that's kind of worded in this way where it says, what is 15% of 100? Well, we know we're not looking for the percent because it's giving us that. This word right here, what is, that's what we're looking for. This keyword is tells you that we're looking for the part. So if you see the word is, that tells you we're looking for the variable a based off of the variables we're using in our formula. We know that P is the percent, and then this of 100, that would be our base. Okay, the word of represents our base, and we'll kind of go over that again shortly. We're looking for a percent when it's kind of worded in this format. It'll say what percent of 200 is 10. Of course, things can be worded in different ways, but these are the most common ways. So again, what percent, this word right here, percent, this one's a little more obvious. This is telling me that if we're being asked what percent, our variable that we're solving for is P. Of 200 is telling me that my base is 200 and is 10, since we already mentioned is basically our part, this is 10, my A value here would be 10. And then if it's worded kind of in this format, 15 is 20% of what number? So this of part, this is what we're searching for. This is my base. So if we see the word of, that's our base. So you may want to add those key words in your notes along with what it typically represents. Part, we're looking for the word is. Percent, we're looking for the word percent. Base, we're looking for the word of. Okay, so if it says of what is, that's telling you what our variable is going to be. Everything else would then be a number. So let's put those topics and that formula and let's use them and apply them for some problems here. So go ahead and copy these down in your notes. Of course, you can pause and rewind as necessary, and I'll walk you guys through these. So 56% of what is 68. So the first thing we want to do here is determine which numbers do we know and which number do we not know, which will be our variable. And again, I'm going to use those key words to help me out here. Before I get started, I'm going to copy my formula. Remember, our formula is percent times base equals our part. So 56%. This is my percent. I know that value. Of what? That's the part that I'm looking for. And remember, this word of is my base. So I don't know my base here. This is going to be my variable in this particular question. Is 68, that keyword is, tells me that my part is 68. So I'm going to substitute everything here into my formula. But remember, when we're multiplying with a percent, it's easiest to work with the decimal. You can write it as a ratio over 100, but then it's going to be in fraction form. I think it's going to be easiest to work with the decimal here. So to find the decimal version of 56%, I can either take that number and divide by 100, or I can use the shortcut method where I take the decimal, and if I don't see one, I know it's all the way on the end, and I move it 2 spaces to the left. So this gives me 0.56. This is just to allow me to work with a decimal as opposed to a fraction. And I'm going to substitute that for my variable P. I don't know my base, that's my variable here, but I do know my part is 68. So all I did was I used these keywords to figure out what numbers do I know and what's my missing piece. And now I can isolate this variable using inverse operations. This is a one-step equation. 0.56 is being multiplied with my variable b. The opposite of multiplying is to take this number and divide each side by it. So if I do that, that's going to tell me that my base is equal to, and I'll just divide in my calculator, 68 divided by 0.56 gives me 121 point, and I get some decimals here. So for this particular lesson, I'm just going to go ahead and say, let's just round things to the nearest tenth. So now more than ever, it's really important that when you guys are doing any type of assignment for your teachers, if it's involving percents and things that don't terminate nicely, you want to make sure to read the directions to see if it gives you specific rounding instructions. If it says round to the nearest whole number, you'll round to the nearest whole number. If it says round to the nearest tenth, we round to one decimal place. I'm just going to round to the nearest tenth for these examples today. So if I round to the nearest tenth, I'm looking at the 4 and I'm using the value just to the right of it to help me round. If it's 4 or less, I'm going to let that value rest. So this tells me I'm going to let that 4 rest. There's my answer. Okay, so here is my base. I can't really write the B because my little box right here is in the way. But this is my final answer here. Let's do another example. What is 67% of 109? So again, I'm just going to start by writing my formula. Percent times base equals part. So P times B equals A. And I'm going to go back to the question to determine what do I know and what do I not know. What is? This is the part that I'm being asked to solve for. This keyword is tells me I'm looking for a part. Everything else should then be numbers in my formula. 67%, well, there's my percent. And then of 109, this keyword of tells me this is my base. Okay, so I'm just going to substitute everything that I know into this formula and solve. Now, remember, if we're given the percentage here, the easiest way to work with it in my formula is as a decimal. So I'm just going to take that percent, I'm going to add that decimal that I know is understood to be on the end, and I'm going to move it 2 places to the left. This is the same thing as taking the number and dividing it by 100, and this tells me that 67% as a decimal is 0.67. So this is what I'm actually going to use as my percent here. 0.67 times, I know my base this time is 109. I don't know my part. So here, to solve for my answer, my part, I don't need to use inverse operations at all. My variable's already isolated. I just need to multiply to get my answer. So 0.67 times 109 tells me that my part is 73.03. This does terminate nicely, but again, if I'm going to round it to the nearest tenth, that means I would round the 0, and the 3 next door would tell me that that 0 would rest as a 0, which I could either write as 73.0 or just 73. Okay, a few more examples and then I'll give you guys some to try. Again, I'm going to start by writing my formula. I'm going to do that before I even read the question. Percent times base equals part. P times B equals A. What percent of 88 is 57? What percent? That's the thing that we're looking for. So in this particular example, we are finding the percent. We need to be really careful with ones like this. I'll show you why in just a moment when we start working it out. Of 88, that keyword of tells me that this is my base. Is 57, that keyword is tells me that this is my part. I'm going to substitute everything I know into my equation here. This time I don't know my percentage. So P times 88 is my base. So I'm just replacing B with 88 equals 57. So I see that there's a number being multiplied with my variable here. The inverse is to divide. Now when I do that, it's going to give me a decimal. 57 divided by 88 equals 0.647, and then it just keeps going. Okay, so when we're solving for percents, it's going to give us the decimal version of that percent. So just like when we were converting the percentages to a decimal to use in our formula, it's kind of the opposite here. When we're solving for the percent, we're given the decimal as the answer, and then we need to convert it back to a percentage. So if converting from a percent to a decimal, the shortcut was to take the decimal, move it 2 places to the left. The opposite, to go from a decimal to a percent, is to take that decimal point and move it 2 places to the right. Because you have to remember, this is really a number out of 100. Okay, so this number, if you think about it, this was some value divided by 100, which is how we got this decimal. So to go the other way, we need to move the decimal 2 places to the right. In other words, we're multiplying it by 100. So you may want to add some notes to question 3, that when we go from a, let me write it over here. Hopefully I can write it small enough. Actually, let me just finish writing my answer here. So if I move my decimal 2 places to the right, this is going to tell me that P really equals 64 point, I'll throw on an extra decimal here. There was another 7 here. Okay, so it's 0.6477. So it was 64.77. And again, I'll just round here. So I'll round that to 64.8%. Okay, so I'm just using this 7 here to bump this 7 up. Remember, if it's 5 or more, you raise the score. So again, you may want to just add some notes to your problem here, that when we go from a percent to a decimal, we move the decimal 2 places to the left. Okay, so for example, a 24% would be 0.24 because I move it 2 places to the left. If I go the other way though, and I have the decimal, if I go from a decimal to a percent, I have to do the other way. I have to take that decimal and move the decimal point 2 places to the right. And this would give me my percentage. So you may just want to add some additional notes to this particular problem here. Okay, when you're solving for the percent, you're going to be given that decimal version of the answer. So you have to convert it back to a percentage. Let's do one more like that, where we're finding the percent. So what percent of 98 is 86? Again, we're asked to find the percent of 98. That's my keyword of, which gives me my base. Is tells me that my part is 86. So I'm just going to substitute everything I know into this formula here. I don't know my percent. I know my base is 98. I know my part is 86. And I'm going to do the same thing like I did over here. This is a one-step equation. To isolate my variable here, I'm going to do the opposite of multiplication, and I'm going to divide. And when it gives me my percent, it's going to give me the decimal version of that answer that I then have to convert to a percentage. So 86 divided by 98 gives me another decimal. It's giving me 0.87755, and it just keeps going. So to go from a decimal to a percent, I need to take this decimal point and move it 2 places to the right. So if I look at this, this is telling me I'm getting 87.75, and it just keeps going. So I'm going to round to the nearest tenth here. So I'm going to round the 7 up because this is 5 or more, so we raise the score. So I'm going to get 87.8%. Also, something important to note here, when we are solving for a percent, we throw a percent symbol after we convert it back to that percentage. Okay, So those are all three types of percent problems that you can come across. I'm going to go ahead and pause the video here to give you a chance to try some on your own, and then when you unpause, I will reveal the answers. All right, so here is what I am getting as my answers, and hopefully we match. So no, for number 5, we were looking for the base. It said of what, so that was my variable. I had to take my percentage and convert it to a decimal. Notice how I just didn't include the 0 on the end. 1.90 is the same thing as 1.9. I substituted everything into my formula, percent times base equals part, and I rounded my final answer to the nearest tenth. For number 6, the missing part, it was asking us what is. The keyword is tells me I'm looking for a part. So again, I have to take this percentage, take the understood invisible decimal, move it 2 places to the left, and use the decimal version of my percent in my formula. And then this did terminate nicely, but I just went ahead and rounded to the nearest tenth since I'm basically doing that for a lot of the other problems anyways. And I got 15.0 or 15 for my final answer. What percent of, so what percent, that's the part that we're looking for, that's my percentage. And again, these are the ones where you have to be really careful. When you get your final answer, it's going to give you technically the decimal version of your answer. So take the decimal point wherever it is, and we do the opposite of when we're going from the percent to a decimal. When we go from a decimal to a percent, we take the decimal point and move it 2 places to the right. So when I did this, I went ahead and just rounded to the nearest tenth. So it had a bunch of 6s repeating. So if I wanted to round this tenths place, I would use the 6 next door to bump it up to a 7. And since I'm solving for a percent here, I put a percent symbol in my answer. And then the last question, what is, so it was very similar to number 6. We were solving for that part again. So I take my percent, move the decimal 2 places to the left to make it a decimal version, substitute everything in my formula, and then I simplified and rounded. So hopefully those weren't too difficult. Let's go ahead and do some more application problems, some more real world type of problems. So if you think about where percents are most often used in the real world, we typically use them when we're talking about shopping, right? So we use them in stores. So let's take a look. Let me just clear my board real quick. Oops. And let's take a look at some application problems here. So we have a used car lot. A used car lot runs sales at the end of the year to reduce inventory. This year, the sale price is 15% less than the regular price. If the regular price of a car is $12,000, what's the sale price of the car? So we can still use that formula to kind of help us here, but we need to be really careful with how we approach these application problems because it's not as obvious what it is we're looking for, whether it's the percent, the base, or the part, because it's not really wording it in the same way. So the first thing that I do when I'm looking at these types of problems is I ask myself, is the answer that I'm looking for going to be some sort of discount, something that's going to be less than the original price? Or is it going to be a markup of some sort where it's increasing the original price? So a markup is kind of like the opposite of a discount. It's what stores will do to the price of something to earn a profit. So it's telling us that the sale price is going to be less than the regular price. Okay, so this is kind of like a discount problem. It's also telling us that it's 15% less than. So we're going to have to figure out what is 15% of this and then subtract it. Okay, so we're subtracting here. So here's my percent. This I know has to be a base because this was the original price. This is like your total, okay? So the first thing I need to do is I need to figure out what is the discount essentially, and then subtract that from the sale price, okay? So let's find, whoops, the amount of discount. That's kind of what we're finding here. And then to find the sale price at the very end, We're going to take the original price of $12,000 and we're going to subtract the discount. So to find the discount, I'm just going to use my formula, percent times base equals part, where in this case, my part is going to be the discount. Okay, and I'm just going to convert this 15% into a decimal. Again, to do that, I look at this as if it's an integer and move my decimal point 2 places to the left. So that's going to tell me that 15% is 0.15. So I'm going to take 0.15, multiply it with my original cost, which is $12,000, and this will give me my discount. So I can just use my calculator here, 0.15 times 12,000. We're just simplifying here, and that's giving me 1,800. So again, this is the amount of discount that we just found. This is not the sale price. This is how much we're saving, right? So the sale price is 15% less than the regular price. So we're taking this amount of discount and we're subtracting it from the original price, and that's the actual sale price. So to find my sale price, I'm going to take 12,000, subtract that 1,800, and that's going to tell me that the sale price of the car is $10,000, $10,200. Okay, so a couple added layers of difficulty for these application type problems. It's not explicitly telling you whether you're looking for a percent, base, or part using that same format as before. So we kind of have to do a little bit more digging to figure that part out. And also, when we're talking about application problems, we typically have to do something like this, where we take either the discount and we subtract from the original price, or we take the markup and we add it to the original price. Because again, a markup is like the opposite of a discount. Rather than making something cheaper, okay, this is cheaper than the original price, a markup makes something more expensive. Let's take a look at another example. A friend purchases items for a wholesale website and resells them on her own website. She typically marks up her merchandise 40%. So again, she's making it more expensive to earn a profit. If she purchased an item for $15, what price should she set for that item? Okay, so again, it's telling us that she's marking it up 40%. So that I know is my P, my percent. She purchased an item for $15. The original price of something is always our base, okay? Because it's the total or the original or the whole amount. What price should she set for that item? So in order to do this, the first thing I need to figure out is, well, what's going to be the amount of markup? The amount of markup is going to be found the same way that we solved all the other percent problems. We can just use our formula, percent times base equals part. The part, just like when we were finding the discount, this was the discount, this is going to be the markup. The part is always going to be either your discount or your markup. And then to figure out what she's going to sell that price or sell that item for, her selling price is going to be found by taking the price of the original item, which was $15, and rather than subtracting, we're going to be adding. Because remember, she's making it more expensive. She's adding to that price. So she's adding her markup. And that's what she's going to sell the item for. So I know that 40% is what I need to use for P, but I need to take that 40%. And again, I understand that there's an invisible decimal here, and I need to convert it to a decimal. And the decimal version is what I will use. So 0.40 or 0.4, that's what I'm using for my variable P here. The original price is always our base, and I'm searching for the part, which is my markup. So 0.4 or 0.40, however you want to write it, they mean the same thing. I multiply that with 15, and I'm getting 6. Okay, so 6 is her markup. Okay, this is her markup right here. So I'm going to take the $6 and I'm going to add that to the original $15. And this is going to give us what she's going to sell the item for. So if I take 15, add 6, she's going to sell the item for $21. Okay, and then the last thing that we're going to cover, we did cover quite a lot in this particular lesson, is finding the selling price of a particular item. So this is basically kind of what we just did, but rather than putting it in the format of a word problem, I'm explicitly telling you this is the original price, this is the discount percent or markup percent, depending on what it is we're looking at. And then we do something similar as before, where we either subtract the discount from the original price, or we add the markup with the original price. So a discount, again, you subtract because it's making it cheaper. A markup you add because it's making it more expensive. So I'm just going to do like I did before, where I'm substituting. I'm first substituting into my formula, percent times base equals part. This is going to give me the amount of either discount or markup, and then I either subtract that amount or add that amount accordingly. So first thing I need to do is I need to take this 5%, convert it to a decimal. When I do that, there's this empty space here that I need to add a 0 into. So it ends up turning it into 0.05, not 0.5. That's really important, that when you move this decimal 2 places to the left and there's that empty gap there, that's really an invisible 0. So we need to make sure that we're writing this percentage correctly as a decimal. So I'm going to substitute all of this into my formula. Again, the original price is always your base. So here's a base, here's a base. Original price is always the base. And I'm going to substitute everything in. 0.05 times my base of 37,000 will equal my discount. Okay, so this is the discount. And I can just use my calculator to make quick work of this. I'm getting 1850, and I'm going to take the original price of 37,000, subtract that discount, and that's going to give me the selling price. Okay, so 37,000, subtract 1850, and that gives me 35,150. Here's my selling price after I subtract that discount. Let's do another example. So in this example, it's a markup. So at the end, I'm going to have to add to the original price. But first, I need to figure out what's the amount of markup in terms of dollars. I know the percentage, but I need it as an amount of money. So again, I need to take this percent of 40. There's an understood decimal here. Move it 2 places to the left. This makes this a 0.40 or 0.4. I'm going to substitute that into my formula. The original price is always my base. I'm looking for the part, which is my markup. I'm just going to use my calculator here to multiply, and it's giving me a decimal of 39.98. Again, this is my markup. So to find the selling price, I got to take the original amount, and a markup's going to make it more expensive. So I'm going to add here. So I'm just going to add using my calculator, and I get $139.93. Okay, so here are a couple for you to try. So I'll pause the video here, and when you unpause, you should see some solutions. Okay, so here's what I'm getting as my answers. Now, the interesting thing about both of these examples is that you actually wanted to add at the very end for both of them. We didn't really talk about an example like this yet, but hopefully you know that when you go to purchase something at a store, you get taxed on it. That tax is going to make something more expensive. So in this case, this is very similar to a markup. We approach the problem the same way. We first find the amount of tax by using our formula percent times base equals part. Again, the original price is always going to be our base. So this is a base, this is a base, and the percent is going to be given to us that we have to first change to a decimal. And the part that we find is going to be that amount, whether it's a discount or amount of tax or a markup, it's going to be that amount in the form of dollars. And then we need to add or subtract that to the original price accordingly. So a tax, because it's making something more expensive, we're going to add here. We're not going to subtract. It would be nice if we saved money from taxes, but unfortunately it makes things more expensive. So this is what I ended up getting after adding, and then I just rounded at the very end to the pennies place, which is the hundredths place. And then same thing for 14. I ended up getting a decimal at the very end, but I just rounded to the pennies place, which is the hundredths place. So I believe that ended up being the last slide here. Let's just double check. Yep, that was it. So hopefully you didn't find these too difficult. Of course, if you have any questions, feel free to reach out to your teacher, and I will see you guys next time. Take care.